Hello, my name is Masahiro Tanaka. I am a researcher at NICT in Japan. In this video, I will talk about RaNNC, our automatic parallelization middleware for training extremely large-scale neural networks. In the area of deep learning, the sizes of neural networks have been rapidly increasing. To train extremely large networks like GPT-3 and MT-NLG, we need to partition them for model parallelism, since the parameters do not fit into the memory of a single GPU. The existing frameworks for model parallelism have some issues. First, users need to implement and optimize partitioning by themselves. Next, some frameworks like Megatron-LM are applicable only to transformer family networks like BERT. To address these issues, we developed RaNNC, a middleware that can automatically partition various types of networks for model parallelism. The initial ideas of RaNNC were published at IPDPS 2021, the IEEE International Parallel and Distributed Processing Symposium. To explain the usage of RaNNC, let me begin with a typical training code. In this code, we have the declarations of a model and an optimizer, forward and backward passes, and a parameter update. When you use data parallelism, you just need to insert one line that wraps the model by distributed data parallel module. Model parallelism, however, is much more difficult. When using Megatron-LM, for example, you need to significantly change a model's definitions using special operators for distributed computation. This is very tough even for experts. Users need to consider computation loads of the model, memory usages, and communication overheads. Unlike Megatron-LM, RaNNC automatically partitions the network and parallelizes training, so you don't need to change the definition of the network. You just need to insert one line, similarly to data parallelism. RaNNC partitions a PyTorch model to submodels so that each submodel fits to a GPU memory and that a high training throughput is achieved. Submodels are replicated for data parallelism whenever possible. Our experiments using enlarged BERT and ResNet showed that RaNNC achieved better or similar throughputs compared to other frameworks. Using RaNNC, we were able to train a BERT model with approximately 100 billion parameters without any manual tuning for parallelization. RaNNC is now available on GitHub with examples of large-scale model training. Thank you for watching this video.